Hi, and welcome back to another VC Libraries Open Code Review. Today we'll be looking at the STL's favoritist attribute in the whole world, nodiscard. We have a PR from our contributor Alex Gutenev, number 2211, nodiscard messages. So we'll be looking at this, which addresses a couple of enhancement issues that we had filed a while ago. But first, I wanted to give some background on what is this attribute, what does the STL use it for, and what do we want to do in this PR. So if you haven't heard of nodiscard or attributes in general, they're a way to mark things like functions or data members, but in this case, it's applicable to functions in ways that don't necessarily carry required semantic meaning for the compiler, meaning that in theory, the attribute should be ignorable and you should still get the same behavior you would otherwise. But sometimes it can help the compiler emit better code gen. It can help the compiler emit better diagnostics, things like that. This rule isn't strictly followed by the standard. There's things like no unique address that do have a bit more of an effect than others. Nodiscard is very much a classic attribute where you could ignore every single nodiscard in the program, and aside from compiler warnings, it should have no effect. But the effect that it does have is quite useful. So I can open up, let me open up the STL here. Locally, and if I do a search, a global search for every occurrence of nodiscard, we use a macro in our product code that is internal to us. It should not be used by users. Discard, if I can type correctly. Here we go. There are 5,541 occurrences of this nodiscard annotation in the STL. We use this everywhere, and in fact, we use it much more than suggested by the standard. All of this is quality of implementation. Implementations of the STL are not required to use nodiscard, but we love it so much, we've put 3,000, 4,000, 5,000 and counting occurrences. So why do we do this? Why is it so important to not discard the results of functions? So I've seen when talking to people, reactions to nodiscard are sort of split. Some people are like, as soon as they see it, they're like, oh, cool, I should go use this. And other people are very skeptical. And it's reasonable to be skeptical of a new technology, especially if it increases verbosity. If you've got a function like, say, nodiscard, int square, taking an int n that returns a couple n's. Here I can print out the use of square, and it should print. There we go. Once I get the syntax right. Yeah, so that works fine. So what nodiscard does is it diagnoses incorrect uses like this, where you call a function, it drops the return value on the floor, which is valid, but here the compiler will warn, because we marked it as nodiscard, warning, C4834, discarding return value of function with no discard attribute, which is a reminder to the programmer that, hey, did you mean to do something with square 5? Here, this function is an example of what we call a pure observer. It exists only to take some arguments, compute some stuff, and return it. So if you drop the return value on the floor, why did you call the function in the first place? It had no side effects. So this is the most common reason we mark things as nodiscard in the STL. So one of the reasons why we can use over 5,000 occurrences is that as long as your program's operating properly, you're actually using all the return values that we've marked, you get no warnings. As long as we're very careful to apply nodiscard only when we're highly confident that warnings will indicate actual bugs or actual forgotten code, then we avoid the false positives, because users hate false positive warnings. They're noisy. They cause people to just turn off the warning with our warning disable switch. That would significantly degrade the utility of the feature. So with nodiscard, we try to strictly apply it to cases where we're highly confident that it's going to find actual problems. And only in a couple places have we been a little bit too overeager with nodiscard and have had to pull it back. It does mean that there are some cases like unique putter release, where 90% of discards are a bug, but 10% are maybe valid. And because of that 10% that we don't want to emit noise, we don't mark the thing as nodiscard, even though it would find bugs. The cost in false positives is too great. So maybe this is compelling, seeing this nodiscard saying, oh, wow, you caught a bug. But maybe you're thinking, oh, okay, how often am I going to, just call a function, drop its value on the floor, and I wanted it anyways? How bad could that be? So let me present the most compelling reason that I've seen for nodiscard. It has found a few bugs in production code bases. So let's change this. let's have a couple containers. Let's have this be 10, 20, 30. Vector in v2 is 40, 50, 60. Let's iterate over both of these containers simultaneously. So for auto I is v1 begin, comma, j is v2 begin, semicolon. The condition, as long as I is not equal v1 end, comma, j not equal v2 end, semi, and then we want to increment I, comma, increment j, and then we're going to say cout. We'd like to dereference the iterator. Nope, can't do that. Deref I, and then a comma. I see Casey and Nicole are smiling because they know it's coming. Deref J, and then maybe print a new line. Okay, and let me warning disable 4834. So we pretend what happens if the STL does not have no discard warnings. What happens here? Okay, so maybe I'll put a space here to make it pretty. So hey, this program compiled, it ran, it worked, everything's good, right? I mean, I got 10 and 40, 20 and 50, 30 and 60 printed. Well, there is a bug here. Let's see what the bug is by enabling the no discard warning as it is enabled by default. And think. Why am I not getting the no discard warning? We're under latest. Did the thing actually recompile for us? We totally should have gotten the warning here. Yeah. Sometimes I've seen Compiler Explorer doesn't always recompile. Okay, now I have a mystery because this really should have emitted the no discard warning. Let's see, we've got iterators. We are totally, oh, I think I found a compiler limitation here. It's a good thing we've got a compiler dev on the call. Okay, so this is interesting. Let me downgrade us to CS+17 because I really want this example. Then we'll talk about what I think I just discovered. Okay, everybody's learning something today, including me. So it's compiling under 17 mode. Here we go. Okay, so this is the warning I expected to see. And then in a bit, we'll get to why we didn't see the warning. So we get a squiggle on line 11. Warning, discarding return value function with no discard attribute. Oh, that's interesting. I said I not equal v1 end, comma, and I put that comma in there intentionally, j not equal v2 end. This comma is wrong. The comma here is necessary because you got to define two variables here. The comma here is necessary. It's a comma operator. We're going to increment both I and j. Here you do not want a comma because if you put a comma there, we ignore the left-hand side because we compare two iterators. We got a bool, then we drop it on the floor. And the result of this is only j. So what we really wanted was operator and. This is a bug. And the reason why I say this is my favorite example is we have seen like at least 2 or 3 occurrences in real production code bases, I will avoid naming names, where people shipped this to users and the code was behaving incorrectly. And in this case, it misbehaves if the vectors are ever different lengths. You want this to end as soon as one of the 2 vectors is exhausted and not only when the second vector is exhausted. So having a comma there is a real bug. In this case, it seemed to work fine. But if I had, let's see, if I have too many elements, we would end as v2 end, so it would seem to work fine. But if v1 does not have enough elements, the and will work properly, where we stop as soon as we consume the final element 20 of v1. But the comma will give us undefined behavior, and it will be diagnosed in debug mode. Oh yeah, let's disable the no discard warning 4834. And if we compile in debug mode, we'll get the debug assertion. Yeah, where think. Yeah, it intentionally crashes because we get our debug check. And in release mode, we briefly saw you get undefined behavior, but in practice, what we get here is garbage. So there's a real bug if you say comma, and no discard catches it because it gets the library to communicate information to the compiler. The compiler just sees a function call here. Operator not equal for a vector int iterator, which is a class type. It's reasonable to call a function and then drop its value on the floor. That's what happens when you call printf. Did you know that printf returns an int? Almost everybody ignores that int because it's not really useful. But here we really want this pure observer not equal to not be discarded. So nodiscard will find bugs. You want this enabled. We do enable it by default. And ideally, point of this code review is to try to convince you to start marking your own functions as nodiscard when they meet the proper criteria. Yes, it's a little bit of verbosity. Almost always it's not going to find anything, but when it finds something, you're going to be really glad. Okay, so let's pop the stack here and let's go back to why we did not see this. I think CS+20 will find the issue. So in C++20, we've got the comma here and it's not diagnosing. So I think this is actually a compiler bug. I'm going to need to report this after this video, or perhaps one of the STL maintainers here can report the compiler bug as I talk. The issue here is that I am calling operator not equal. In C++20 mode, we got the spaceship operator. And along with the spaceship operator, we got a bunch of cool rules that says that a class only needs to provide operator equal. Let me add some comments here, op equal. And then if you provide operator spaceship, then the equal will be used to generate not equal. Or really, if you say not equal, it gets rewritten. I should say rewritten. So usage of not equal is rewritten. Written to equal. And with spaceship, any usage of less than, greater, less equal, greater equal is rewritten to spaceship. There's articles that will explain why equal and spaceship are treated differently, but the quick answer is that for some things, equality can be answered faster than a full less than or greater than comparison. For example, if you have two vectors of different lengths, we can see instantly that they are non-equal by just comparing their lengths. Whereas if you want to know, is one less than the other, we actually have to look at every element, because if one has the same elements as another and is simply a prefix or a suffix, then we actually do need to compare all the elements until we exhaust one of them. So that's why they can't be fully unified all the time into just spaceship. But we can always generate, or we can always rewrite not equal into equal. And the STL now takes advantage of this. In CS+20 mode, I can actually dig up the relevant code. Let's go to vector. Here we go. Let's just search for occurrences of operator equal. So in our internal implementation, vector iterators, we have something called underscore capital vector const iterator and another one for modifiable iterators. We always provide an operator equal. In C++20 mode, here's our internal macro to indicate that we also provide a spaceship. In non-C++20 mode, we then need to provide not equal, less, greater, less equal, greater equal. But when we're in 20 mode, all we need is equality and spaceship, and the rest will be rewritten to one of these two. So going back to why I was momentarily confused, we have very carefully marked all of these things as no discard, because calling any of these iterator comparisons is a pure observer. And if you drop that on the floor, well, you probably have a bug, like I just showed. However, this has shown that if the user has written, me being the user, not equal, and then the compiler says, oh, we're in C++20 mode, I'm going to rewrite that into equal because I see that operator, and this iterator class did not provide a not equal operator. When the compiler does that rewriting, it is not carrying along the no discard. We marked the actual operator that's being called as no discard, but that bit is being lost when the rewrite happens. That should not be the case. For this rewrite, if the function that's ultimately called is no discard, then the rewritten call should absolutely emit a no discard warning. So we should get a warning for that. I see a new bubble in the chat. Did we get something? Here we go. Okay, yeah, Casey and Nicole are asking who should report. Cameron, our compiler dev, says, can't confirm, I have a bucket of Casey bugs. And Nicole reports that GCC exhibits the same bug, but Clang does not. So we have some compiler variation, but hopefully in the future, all compilers will properly carry over no discard. So this is actually good to know. I did not realize that this was language mode sensitive until I wrote this example. So Casey has one argument that it's not a bug, that not x equal y doesn't discard the result of x equals y, but it's really the compiler should, because the compiler's doing the rewriting. So it can see that the top level invocation is being discarded, and it really should. And then, yeah, Cameron has an example where Oh, interesting. So I wonder why Clang handles some of them. Okay, so a little bit more investigation needed there. So that's the idea behind nodiscard. Now let me quickly explain what this PR is going to look at. Nodiscard was added in C++ 17, and we are now using that. In fact, we use it even in C++ 14 mode because we have it's permitted as future technology where features from future standards are supported. And CS+20 added nodiscard with a reason. So you can now put a string literal in nodiscard. Let's see what that looks like with the compiler. Let me get rid of vector here. Okay, so let me go back to this example. Nodiscard, pure observer, and square, and n, return n times n. Okay, so I can see out square 5 and everything is good. 20 mode, warning's enabled, it works. But if I call square 5 all by itself with a semicolon, what happens? Okay, we get warning. Now the number's changed, 4858. I think that is different than before. Discarding return value pure observer. So whatever string literal you put in this nodiscard gets emitted. I guess I can try both. What if we don't have the reason? What if we were cubing something? And then we call cube of 5. There we go. Okay. Okay, yeah, indeed, they are different warning numbers, and we can customize the message with nodiscard with a message. So we had filed an issue early on in the repo's history, noting when this feature was voted in. And one of the to-dos that we had in mind was maybe we could use this in the STL to provide a little bit more context to users. So as I mentioned, we have a few criteria which we've sort of mentally laid out, and we've explained it like to the standardization committee a few times, because the standard is now marking a few things as nodiscard, which strongly suggest to implementers that they do that in their implementation, although it's not a binding requirement. Why you would want to mark things as nodiscard. So by far the most common reason is pure observers, things that do not have side effects, or they have side effects in very rare and unusually pathological cases. So comparisons, those are almost always nodiscard. Another example is like stood find. Stood find takes a range of elements and a value, or find if takes a predicate and looks for the first occurrence of an element that's equal to the desired one or satisfies the predicate, and then returns an iterator to it, or the end iterator if it didn't find anything. That is a pure observer, and if you call a find and you drop the value, the iterator on the floor, you've probably done something wrong, or you're just spending cycles when you don't need to. It is true that either the comparison could have side effects because it could go log something or go modify something, or especially the predicate form could go have side effects somewhere. Even while it upholds the standard, while it's conformant, as long as it returns consistent results for the same input, the standard actually doesn't care if that predicate has side effects. But it would be very unusual to call a find only for the side effects of the predicates. Doesn't mean it never happens. In fact, I've seen the compiler do it once or twice, but it's very unusual. So this is not the case where like 10% of calls are totally valid and 90% of calls are bugs, but we care about the 10% we want to avoid marking things as nodiscard. In the case of like find, 99.99% of invocations that are discarding that iterator are doing so incorrectly. And for that point, 0.001% that really do want those side effects, it's reasonable to ask those users to silence the warning in a targeted manner. So applying like /WD 4834 or WD 4858 to silence these nodiscard warnings, that's a very large hammer. You don't want to use that because it shuts up every single nodiscard warning. Instead, if you see a nodiscard warning and you want to silence it, you can just cast the thing to void. This will tell the compiler, hey, I really did mean to call this thing, and then just ignore what it does. Most of the time, in fact, almost all the time, this should not be necessary. But if you ever see a nodiscard warning that is validly marked and yet your usage is valid, put a void cast there. And if you don't like paren void, you can also do static cast if you really like this. Yes. Most of the time, this happens in a compiler and library tests. because we're very interested in writing expressions that we verify compile or don't crash the compiler, but we're not actually interested in what they do, so we just drop the value on the floor. So most of the time, it's the actual library implementers that have to go add a bunch of void casts, and we have had to do this in a bunch of places. But in user code, unless you have similar sort of tests, this should almost never be necessary. Okay, so I mentioned pure observer is the most common reason, but there are other reasons that you would want to mark something as no discard. So off the top of my head, there are functions that are easily confused. So vector empty is the classic one, where if you want to get rid of all of, I'm trying to avoid the words here. If you want to get rid of all of the elements in a vector, you might say v.empty, because empty sounds like a verb. Unfortunately for the STL, empty is an adjective and it returns a bool. So if you call empty and you drop it on the floor, you've done nothing rather than wiping out all your elements. What you meant to say was v.clear. So this confusion is so notorious that the standard itself has marked vector empty as no discard. I can actually bring that up if people are interested. Now, for us, that doesn't actually make a difference because vector empty also falls under the pure observer criterion. So we would mark it for that reason alone. But even if you didn't have, the willingness to go mark 3,000, 5,000 functions in your STL as no discard, the commonly confused case is a justification. Let me actually just bring this up so we can see what it looks like. Here's vector. Here's the class definition. I scrolled down a bit, and I've scrolled too far. Here we go. Empty in the standard is depicted as no discard, a non-binding suggestion to implementers that they actually mark it. So pure observers commonly confuse functions. Other ones are cases where dropping the return value on the floor is likely to be incorrect or a memory leak or a resource leak. So allocate, raw allocation functions, those should totally be marked as no discard because you either need to store them in a resource management object like a unique put or something, or you need to manually ensure that you deallocate, free, release, whatever the thing, and that you don't leak during exceptions. So at raw resource allocation functions, those should be marked no discard. And another more obscure case is where you're not going to link resources, but if you discard the result, you're going to skip some important second follow-up step that would make your program incorrect. So the example there is like stood remove and stood unique, where those are so notoriously confusing. They had to be an item in Scott Meyer's effective C++ books, where the algorithm sort of compacts the good elements that you want to retain at the beginning of the range, leaves the remaining elements in some garbage unspecified state, and then you need to follow that up with a call to container erase to actually physically make the container smaller and get rid of the garbage elements. So if you say stood remove or stood unique, and then you drop the return value on the floor, you have a bug. Even though it's not a pure observer, because it's really modifying stuff, it's not allocating memory, it is skipping that second step that you need for correct program. So that's a case for no discard. So no discard with a reason is a way for the STL to communicate to users why you would want to do this. So that's what these issues we're talking about, and that's what Alex Guteniev has gone and done. So this pair has been open for a while. We're now finally getting to review it. Apologies for the delay. Let's actually take a look at the code. Okay, so what Alex is doing here is taking that macro, which we mentioned, underscore no discard, which is for the STL's internal use, and replacing selected occurrences with other macros. Because oftentimes the message that we want to give is repeated in a whole bunch of different places. Like we got stood remove if, ranges remove if. They all have the same rationale. So we can just use the same message for all of them, and centralizing that in a macro is reasonable. In the future, we might make the message itself a macro and otherwise use an attribute. The reason why we're using an attribute for no discard is partially for historical reasons, that we added it when not all compilers supported it. That we may be able to change that now, especially since we like no discard so much and we have not had cases where users had needed to activate the escape hatch. But for the time being, putting the whole attribute in a macro is what we do. So first I'd like to look at the macros, make sure that all of them make sense. I'm gonna skip reviewing the actual grammar of the messages for now. I'll come back and do that later. And then we'll see if they're being applied to all cases properly. and if we're forgetting anything. And if I could make this highlight go away, that would be good. Okay, there we go. So let's Alt-click and see what files are being modified. So although it looks like 257 lines are being modified, it's really just a scattering. This PR is not as large as it seems, and most of the lines are in YVOL's Core H because it's adding a bunch of messages. So let's see what messages are being added. Okay, so here we go. YVOL's Core H, the STL central internal header. A transition comment because currently VC runtime is not open sourced. This should go to VC runtime H, agreed. So right now, Alex is following the pattern. I see this is essentially following the nodiscard CTOR for constructors because that's a separate feature. So this looks right. Okay, so transition, this should go to VC runtime H. If the compiler does not support has CPP attribute, then nodiscard message of a message expands to nothing. elif has CPP attribute nodiscard is greater or equal 2019-7L. I believe this is the correct value, but let's check. So if we search for SD feature test, this will bring up the standing document showing feature test macros. We're going to look for the CPP attribute nodiscard. And let's find, we're going to skip that. Here we go. Okay. The same value of July 2019 is used for two different papers. Nodiscard should have a reason and nodiscard for constructors. So even though these are different things that we're testing, they have the same value. So 2019-7 is the correct thing. I'd love to double check this because copy paste errors with feature test macros are quite possible. So exact same value, that's good. If we don't have it at all, expands to nothing. Or if we don't have the ability to check CPP attributes, expands to nothing. Otherwise, if the nodiscard attribute is greater than or equal to nodiscard message, then it should expand to nodiscard with a reason. Now there is a transition here that's blocking it for the CUDA compiler because CUDA 10.1 did not support nodiscard message. What has changed fairly recently, I'm not actually sure if it changed. I think it changed after Alex created this PR, but I can check. That was the fastest way is actually in the changelog because I forget what file we modified. We increased our CUDA requirement to 11.6.0. That happened fairly recently. I think it was this PR. Yes. Where we updated our CUDA compiler to the first version that officially supported VS 2022. That also updated its front end. And it is now required, and that happened on June 15th of this year. So it did happen far after Alex originally created this PR. So we should check if CUDA 11.6 supports nodiscard message. I would hope that it does, but it might not because this is a COS plus 20 feature and supporting it in lower standard modes. Actually, no, this should be controlled by the standard mode. This gracefully downgrades. If you have nodiscard, but you don't have nodiscard message, then Alex's machinery just downgrades. So really, we should not need to block CUDA CC if this works. Okay, add a comment. Number blah. As 2791 updated to CUDA 11.6, is this block still, or do we still need to block? The less special casing, the better. Okay, as 2791 updated to CUDA 11.6, do we still need to block CUDA here? Okay. And that is definitely on us for not getting around to reviewing this earlier. We've been slowly getting through the PR backlog. Okay, reloading everything in my head. Transition, this should go to VC runtime H. If we don't have CP attribute detection at all, then expands to nothing. elif nodiscard is greater than or equal to the nodiscard message version, and asking about the CUDA block, not to find CUDA CC. Okay, then expand to actually use it. Otherwise, if the nodiscard attribute is at least the classic value, and I think this is right, but let's double check. Yes, 2016.3 is the original value, correct? Greater or equal, then use it by itself, otherwise expand to nothing. And because the controlled regions here are pretty tiny and it's not heavily nested, we don't demand comments here, okay? So this is, okay, so that's nodiscard message. And then Alex is adding a variant attribute for nodiscard constructor message, because sometimes we may want to mark a constructor with a reason. So if we don't have the attribute, if we can't look for attributes at all, expand to nothing. If we have both the constructor and the reason, then nodiscard CDOR expands to the one without a reason. Nodiscard CDOR message expands to nodiscard message. Otherwise, this is the case where it is not sufficiently new for the constructor, so we have no possible fallback. They expand to nothing. Agreed. And 2 lines are controlled here. This is still okay to not have a comment. And here we can't unify the macros, because if we just use nodiscard message, it would degrade to double bracket nodiscard, but that cannot appear in such old modes or old compilers on a constructor. So this macro is necessary, assuming it's still being used, and I think it is. One thing I like to check for is if a PR has been heavily revised, make sure that all the machinery it's still adding, the need for it has not disappeared during edit. So I'm going to expand everything, search for uses. Here's the definition. Okay, so nodiscard CDOR lock and nodiscard CDOR thread are using it, like ignoring a thread. Okay, it is being used. Good. So this is not stale in any way. Excellent. Okay, so that's nodiscard message and nodiscard CDOR message. So now I'm going to look at the macros that are being added to understand if these are good cases to emit the warning, why we're emitting the warning there, or why, or in this case, I think this PR is converting everyone already had a notice card to reason. So we just need to make sure the reason is unique enough to deserve a message, and think about, are there any cases that are non-obvious that should also be marked? So as I mentioned, the remove algorithms, those are a classic example where they have a second step that needs to be done. So this is definitely good. The unique algorithms, same idea, but a different name. This is sufficiently different enough that I think having a separate macro, we could super unify it into like remove unique. I suppose one could do that, but here, just looking at the message briefly, there's a good reason. Alex has got a good reason for splitting these, because with remove, he suggests using the erase and erase if functions that I added to the standard originally in a TS, but that's not applicable to unique. There's no uniquifying thing that will also sort. So that is sufficient reason to not super unify all of this. Okay, next is empty member function. Although this does fall under our pure observer criterion, this is a very likely bug that new users could commit when you're just using vector for the first time. And although experienced users will understand what happens when they drop, like, a operator not equal on the floor or something, empty versus clear, providing the guidance to call clear is reasonable, and there's only a few occurrences. So having a dedicated message is reasonable. Also because the standard thought it was important enough to mark. Okay, next, empty on an array. That's a pure observer, but there's no such thing as clear. So providing guidance for clear would be wrong. So have special casing this for array also seems reasonable. It could be argued that the user might, that this is more of a pure observer case, but I could see a user converting from like vector to array if they're not really familiar with the two, and then thinking they could empty it out. And having the separate guidance here seems reasonable. Okay. Okay, so it looks like Alex is adding messages for everything named empty. There's one in stack trace, which is the feature Alex himself implemented. This explains how to clear the stack trace. I like this one because since I use vector all the time, I'm like, everything behaves like a vector. I don't need to know any other class. And I might, if I'm not sufficiently caffeinated, say stack trace.empty. Having guidance that explains what to do and how to reassign it is reasonable. And then it looks like Alex just has a fallback empty function, but doesn't need specific guidance for clear. This seems reasonable. And this is sufficiently vague container-like object. That seems right. Empty memfun adapter. For queues and stacks. I was like empty mem underscore fun, but I thought that function doesn't have any sort of empty. But no, it's a empty member function on an adapter. Now I'm currently thinking, do I like mem underscore fn here? Yeah, it's not really a problem for searching because the actual function is lowercase mem underscore fn. Yeah, it's not worth trying to rename. Okay, yeah, queue or stack, and agreed that there's no way to clear. I'll like I mentioned later, I'll do a check for spelling and stuff because that needs to be fixed. So these all seem good. Next up, barrier. So this is the multi-threading, new multi-threading component. If you arrive at a barrier, you should not discard that token. You're going to need it. You're going to need to wait. This is excellent because if you're new to barrier, you might not realize, I didn't remember this case, that we marked this as no discard for an unusual reason. This is a case kind of like removing unique, that it's a multi-step thing. Try wait. Okay, so here I guess we had marked it as no discard, and if you tried to wait for something, you would probably want to know what happened. Like, did you reach the success criterion, or did it time out? So you really should inspect it. I remember there was some controversy / question about, there was some, I'm trying to remember what it was, in condition variable or something. There's like a member function where it was like unique put or remove, or we wanted to mark it as no discard, but users came up with some cases that were like 10%, reasonable 10% of the time, and we ultimately did not mark it. I can't remember, was that try wait or was that something else? Something like that. I guess I can search. It's been a few years.
My
Yeah,
understanding is that try wait like immediately returns you, like, I don't think that there is any reason to call it except to check if something is finished.
Oh, it's like instant, it doesn't take a chrono or something?
Right. That's my understanding anyways. I very well could be wrong.
Oh, because it's latch. Latch is try wait, it just returns a bool. Okay. I was thinking of wait for and wait for until. Okay, yeah, you're right. So in fact, let's check wait for. Let's see, that's future, that's ugly. I don't want ugly. Here we go. So like in condition variable, are we in the normal condition variable here? Condition variable any, we've got wait for, it returns a CV status. You probably should be checking this thing, but there's a few cases where it's reasonable not to, so we did not mark this as no discard. But you're right, that try wait is special, and we already marked it as no discard, so this is just providing a reason. Excellent. Okay. Great. Try change state. What even is a try change state? Interesting. This must be used on things that are not literally named try change state. I would just like to see what it is, and then I'll resume.
Search for the macro.
Yeah. Oh, try lock. Okay. Try lock for, try lock until. Okay. Okay, that seems sufficiently generic. Okay, let me go back. Try change state. Try change state fun. Non-member versus member. Here these are really similar. Is this the first pair that was member versus non-member? I think it is. Everything else here was like member. Yeah, moving unique or non-members for the ones we care about. Empty is always a member function. Barrier is a member function. Try wait's a member function. See, these are the first ones that are free versus member function pair.
I believe that empty has two, one for member function and one for the like stood empty of a container.
Oh yeah, because we have you're right, like size and empty memfun. Oh, empty function. Yes, good catch. Yep, there it is. Yeah, non-member. Okay, so yeah, it's reasonable to have one for try change state and try change state fun.
It would be nice if the things were standardized so that like the member function one is always underscore mem
Always,
underscore
yeah,
fun,
mem fun.
and
Yeah,
the function one is always underscore fun.
yeah. At least in the case where we have both.
Right.
And this one actually spells out function. Empty function, empty memfun. I suppose when I like having the different spelling of function, because that way one is not a like strict substring of the other, but I agree that it should be consistently done. That's worth a comment. Okay,
I would be
so that
I have a concern with calling it function just because that sounds like a very common thing, and I think that function has an empty member variable or member function.
oh, stood function. Stood function does not. It has just an operator, explicit operator bool.
Oh, okay, cool.
You're right that it is a very common word, unfortunately. Standard doesn't quite say free function anywhere. It just says non-member, but non-member fun or something seems very verbose. Let's see, any ideas? There's let's see, the
Could be
closest
memfun without a thing and then just fun. So you could search for like fn with a underscore before it versus memfun.
we could do
No
that. I'm
underscore.
thinking, where is the calling convention thing? I think it said non-member. Maybe case. Okay, let's search for all occurrences of stood call. No, that's gonna be horrible. Fast call. There we go. Yeah, it's an extra def. Why did I miss it? Oh, it's a mit. Okay. So we have non-member call for these horrible macros, and then member call. So that's the precedent where we have to distinguish members versus non-members. We spell out member, and then we say non-member. So for these macros, let me go back to the review. If we followed that convention, which I'm not necessarily saying is a great convention because those macros are horrible, it would be something like empty non-member versus empty member adapter. Member is more common here, but non-member is more common elsewhere. Well, now actually I would say of the cases where we have both, the member one's more common because we have a lot of member functions and then just one non-member function to mention. So how do you feel about like non-member versus member and just not saying function at all?
Seems reasonable to me, especially because nodiscard is not getting applied to like member data or whatever.
Right. Okay. I'll add a comment there. Let's see where to mention it. Yeah, it seems reasonable. Maybe on the first occurrence. So remove alg, unique alg, empty mem fun. Let's see. We should consistently mark these. Let's see. When there are both member and non-member versions of these macros, we should have a consistent naming convention for them. Currently, there's some variation. Example variation is nodiscard empty function is the versus, I'll just get the plain member versus non-member. But, and then the other one was try change state versus fun. Yeah. I want to think thoughts that are bigger than 3 lines. Compared to try change state fun. This is the non-member versus try change state. Okay. Let's see if I can quote. Let's see, I didn't open it locally or open it in the repo. Let me close some of this stuff. Okay, close that. Okay, let's open up the dreaded header X to def, where mortals fear to tread, because calling conventions are horrible. Let's see, fast call. Smallest thing that I can quote here. I guess I could quote individual lines, I suppose. The non-member call versus the member call. Using member versus non-member would be reasonable. Also avoiding possible confusion with std function, as Nicole mentioned. Precedent. Okay, let's see how this looks. When there are both member and non-member versions of these macros, we should have a consistent naming convention for them. Currently, there's some variation. Nodiscard empty function versus nodiscard empty memfun compared to nodiscard try change state fun versus nodiscard try change state member. Using capital member versus non-capital member would be reasonable, also avoiding possible confusion with std function, as Nicole observed, and with std memfun, as I briefly thought, and consistent with the precedent here, quoting non-member call and member call. Okay. Great. Okay, so I was at try change state.
It might be also useful if you go back. Personally, I would appreciate if we had empty array member as opposed to empty member array, I think.
I agree. That is quite reasonable. Trying to think all possible permutations. Reminding me of the recent XKCD comic about tetherballs, rope versus pole versus ball, which orders are most fun. In this case, nodiscard array member empty, because you could say the class name, kind of like, array double colon empty. So you suggested what, empty array member? I agree that putting array member sounds better than member array.
Yeah, that's what I suggested.
So there's empty array member or array member empty. Beginning with the prefix nodiscard empty, even though it doesn't quite follow the order of like declaration where you'd say array double colon empty, this keeps all of the empty, they sort together.
Yeah, I
think that is good. Yeah. Okay. Let's see, I'll add that here. Because it's really just the naming. Chinugin, yeah, that. Additionally, recommends, and I agree that. Okay, so underscore, no discard, empty, and then array member would be easier to read than no discard empty member array. While still having all of the empty macros sort together, because we love sorting. Okay, let's see. Why is this like almost truncated here? Nicole additionally recommends, and I agree, that nodiscard empty array member would be easier to read than nodiscard empty member array, while still having all of the empty macros sort together. Okay, try change state fun. Nodiscard, putter alloc fun. This function constructs an object wrapped by a pointer versus a raw pointer. What is the difference between these two? Putter alloc and putter raw alloc. Oh, raw alloc does not construct, and alloc constructs, or alloc returns like a smart pointer. I'm curious about the difference here. Use this. Make exception putter. So this is resource managed. It's not going to leak, but it makes no sense to call it and drop it on the floor. Make shared. It seems reasonable to have a dedicated one for this. In theory, the construction of the object could have side effects, but then why are you dynamically allocating it? That's interesting. Cameron reports in the chat that he's just fixed the compiler bug preventing nodiscard in CS+20. Thank you, Cameron. That is awesome. Okay, so then raw alloc, this one I assume applies to something like stood allocator and scoped allocator. Yes. And memory resource doesn't directly provide allocator, right? It's or should we be expecting to see polymorphic allocator pop up on this scan? Why is polymorphic allocator not here? Trying to remember like all the stuff we've added to the standard. Okay, who says allocate? It's gonna have a lot of stuff. Who says pointer allocate? Interesting. Memory resource, do you have a polymorphic allocator? Oh no, there's a subheader now. X polymorphic allocator.
X polymorphic allocator, yeah, it should be in has its own header.
We have something called allocate. PMR memory resource has an allocate that returns a void star. It's marked as nodiscard, but this really should deserve a reason. Because it's absolutely falling under the I'm allocating something raw. And I don't think X polymorphic allocator is being marked here. Let me check. No occurrence of X polymorphic allocator. Okay, so we've got a missing thing. It's a good thing I'm reviewing all this. That's a raw pointer one because it is a void star. Okay, so let's quote that. Let's go back. X polymorphic allocator. Allocate paren. Here we go. Is that the only occurrence here? It says void star. Sorry for that if that sound is being captured. Here we go. Okay, that's the only occurrence here. Hit Y to get a permalink. Do I want to show that it's a memory resource? Sure. Okay. Then polymorphic allocator, where does that allocate come from? I'll check that in a second. Let's see, I probably should quote the whole thing. This should be applied to memory resource : allocate. Yes, because it's a raw pointer. Okay, so where does the actual polymorphic allocator class live?
Same file.
Same
Line
file.
206, okay. I think is what you want.
Okay, 206. Oh, we're there. Oh yeah. This returns a tie star. Equally raw. Yeah. So this one should also be annotated. Okay, let's get that. Back here. 206, polymorphic allocator, allocate. This one's, what I really want is the ability to like quote, but then hide lines in the center with like a little expandy. So I don't need to do two separate quotes. So I'm just going to quote one. Polymorphic allocator, allocate. And polymorphic. Mighty Morphin allocators, allocate. Okay. This should be applied to memory resource allocate and polymorphic allocator allocate. Really, one of the things I like to do is think about like all the ways to search the STL, because like a lot of the things I do are powered by searching for every occurrence of a thing. And that's how I learned the STL originally, and I still rely on it a lot. In this case, our internal macro CRT guard overflow is something that we use to tell the compiler that we're going to internally do a multiplication here, in this case, bytes times number of objects. And this tells the compiler to do something very useful, although slightly non-standard, that if an integer overflow / wraparound happens before the function is even called, then that should send, instead of the actual result of the allocation, it should send -1, the maximum value of size t to the function, so that the function can see that, oh, you just tried to allocate a zillion bytes, I should fail. This catches cases where somebody tries to allocate something and they have an integer overflow in the expression passed to allocate. That is extremely likely to be a security bug, and it justifies doing something very slightly non-standard and detecting that bogus code before they call allocate. And it has to be a special decal spec annotation on the parameter, because otherwise there's no way for the library to influence what happens before you call it. So let's search for all occurrences CRT guard overflow. Casey is beating me to the punch and finding cases where users don't directly use stuff. So unfortunately, this is also what we've also marked this at the compiler team's request on a whole bunch of things that internally call allocate pretty soon. These are not raw functions, so they should not be marked, but anything that mentions allocate should. So let's just take a look, regex search for anything that says, and hopefully it should be on the same line and not wrapped, allocate.star. Okay, much fewer occurrences. So we've got CRT allocator, that's an internal type Casey mentioned. Users don't directly call this. So we mark it as nodiscard for our purposes, but we don't need to provide messages, because if this occurs, we're going to know what happened. Scoped allocator, I believe, was already addressed by the PR. Let me split these real quick. You go on the left, you go on the right. Okay, let's journey over to scoped allocator. Yes, pointer allocate and allocate with hint are being marked as raw alloc, so that is done. This is, I wish I had more monitor width.
Allocator traits.
This is, yeah, allocator traits the wrapper in X memory. So we've got, let's see, who is this? Or are these the allocator traits up here? I want to see the context. This is stood allocator. Interesting. Allocator traits on 546 should really be marked too, because it's wrapping the allocator. It happens to say pointer rather than tie star, but if allocate, like, you should not call allocator traits and then drop it on the floor. That's equally raw. Okay, so this is a missing occurrence. We should comment this right now. Let's see, it's allocate at least, and then allocate with hint, right? Yeah, because the wrapper here, let me maximize this quick. It's allocate with hint. Do we have an allocator traits for allocate at least? No, we don't. That's interesting. So it's only allocate and allocate with hint. Okay. Should I quote? Let's quote. X memory. First occurrence of allocate, paren, with a space before. Okay. Normal allocator traits, allocate with hint. Phase 2. I want permalink. Okay. I don't need this anymore. Okay. Maximize. Allocator traits, allocate should also be marked. Yep, nodiscard. It's possible that these were missed because nodiscard was wrapped on a different line than allocate. I'm not exactly sure how Alex found all these occurrences, but I could easily see this defeating a search. I know I've been defeated many times by things wrapping, and I expected the regex to get them on the same line. In this case, nodiscard and allocate were on the same line. Okay, so those two. Okay, we were searching for all occurrences of allocate. So that is traits and traits. And these are the default allocator traits. Oh, on 6, oh, I should also quote this one. 632 and 646. And it's not actually allocator traits. This one is, we have these two specializations for compiler throughput, because allocator traits asks a lot of expensive questions. And if we know it's the default allocator, we can short circuit a lot of that sphening. Like here, this is asking, do you have a pointer type? Do you have a const pointer type? Do you have propagate on container copy? And if we're allocator traits for std allocator, we know the answers to all these questions. We don't have to ask the compiler to do all that work. So let's search for following occurrences of allocate run with a space. And here we go. Default allocator traits, allocate and deallocate. These are kind of widely separated, but I know GitHub will at least abbreviate this when it's a bunch. Default allocator traits. I'll mention both. And back to blah, double colon, allocate should also be marked. Okay. These are all occurring before line 800 something, blah, blah, and blah, blah. Okay. So that's those. Go back to the search. I'm going to want that open again. Okay. So this is the default allocator traits mentioned. And then finally, the std allocator one. These are the ones being marked on the left here. Okay, so these are definitely, whoops, go away. Default allocator traits. Oh, I wanted Alex's PR here. Yeah, 1, 2, 3 for the std allocator itself. And that's 1, 2, and then the third one. Why did this evade my search? Because CRT guard overflow. We're up to the next line. So yeah, so you got all the ones in std allocates. That's good, or std allocator. And then the last ones were the ones we mentioned. Allocate, the memory resource, allocate on the polymorphic, and ooh, hello, you were hiding. Allocate object. Okay, the compiler, the standard just keeps adding stuff. I forgot about this, that this was a thing. This should also be annotated too, because we're definitely allocating a bunch of bytes. When we get the size of the object. Yep, this one. Oh, and it's specific to CS+20. So let's go update that quote. Back to X polymorphic. Allocator, allocate object. Yeah. That was, I think, on yvals that I commented. Yes. Polymorphic allocator allocate and copy paste. Hopefully this is correct. I'm saying polymorphic allocator allocate object. That is correct spelling there. And you are indeed, I'm not getting confused. That allocate object is still a member of polymorphic allocator. It is. Okay, good. Update comments so I don't lose it. Okay, so we are almost done scanning for all allocates. We got all three there, and then the TZDB one is just the CRT allocator. Okay, so that gets all the allocates, which is good. That answers the question, where did polymorphic allocator go? Okay, now assume aligned. So these are the fun compiler wrapper functions. If you say assume aligned on a pointer, that by itself does not have interesting side effects. You actually have to use the thing it returns. So that is a unusual reason to mark something no discard. So message is good. Launder, the even more obscure standard library function. Again, only the return value is specifically laundered. The original one is still dirty. So you don't want to use it. Yep, that's good. Now nodiscard lock suppress. Is this an escape hatch? What is this? Okay, so Alex is introducing an escape hatch for nodiscard lock and nodiscard CDOR lock. That's reasonable. Previously, we didn't have an escape hatch, and we just told users that if they try to do this unusual thing, I guess I can sketch it out. So one example where you can write unusual code, which is technically cromulent. You could say something like, instead of, what is it? Mutex, no, it's lockguard. So if you have a global scope like a mutex mute, and then you say lockguard, guard, my guard, mute, then you can do cool lock stuff. Do cool stuff. And then when it's destroyed, this is not that language. When it is destroyed, the lockguard is destroyed. So this you can do if you name it. We marked all of the lock guards in the STL as either nodiscard on the type, or if they have multiple constructors, some of which should be nodiscard, we mark it on the constructors, so that if you accidentally say this, which constructs a temporary and then drops it on the floor immediately, that is dangerous because you are not actually locked when you do this. You've destroyed it at the semicolon. So that is a very, very important thing to mark. That catches a whole bunch of bugs. However, it can occasionally be used validly. That's if somebody writes something like this. Comma, do cool stuff. Awesome stuff. Semicolon. This constructs a temporary, suspends it in midair, does a bunch of other stuff through comma expressions, and then at the end of the full expression, or the semicolon in ordinary human speak, the temporaries are destroyed. Nicole asked, doesn't that create a default constructed lock guard named mute? Let me think. I think the answer is different for braces or parens. I always get this wrong. By itself, one case will do that. I think with parens, it doesn't. It does. Lock guard with parens. I want to say this one actually creates the default constructed one named mute. This one constructs the temporary, but I'm not 100% certain. We can actually check on Compiler Explorer, open up console.org.
In the comma expression, it can't be a declaration anyway, so it should be fine.
But Nicole was asking about the case where it's just by itself, which I very briefly depicted. So that's the difference between if you've got a mutex mute, and then you have a lock guard, paren guard 1 versus lock guard, brace guard 2. Okay, what happens on 20? 6 cannot deduce. Let's just provide mutex here so we don't have to deal with thinking about CTAD. Custom boundary deduction, mutax, no, that's not a thing. There we go. Okay, 6. Okay, so 6 is trying to default construct. Let me comment this out. Yes, so the parentheses are essentially not doing anything here. They're wrapping the name of a variable in parentheses. So this is not constructing a temporary. It's trying to construct a name variable with no arguments, and here it's complaining there is no default constructor. So you're right. But with braces, this does construct a temporary and throw it away. And we get here, why am I getting undeclared identifier?
It needs to be lock guard mutex mute as opposed to guard 2.
Lock guard mutex. Oh, that's right. Duh. Thank you. Try to construct from mute. Here we go. Yeah, discarding return value. So this one makes it temporary and then does nothing with it because we forgot to say guard. With parentheses, if you tried this would really be redeclaring a variable. If mute is already around in the same scope, redefinition different basic types. But if this were global scope, you could get away with this. And there we go, no appropriate default constructor. Okay, so a reason to use braces. And so essentially what Alex is doing here is we had very intentionally said, we're just going to mark these constructors. And if you try to do the fancy thing with comma expressions, well, don't be so clever. And it is reasonable to have a escape macro here in case you really do want to suppress the warning on those, but without having to refactor code. As long as it's enabled, as long as the nodiscard warning for the guards is enabled by default, I have no objection to the escape hatch here. Essentially, if that lets people enable nodiscard for most of the time and write their unusual code, then that's reasonable. Okay, so if def nodiscard lock suppress, we might want to rephrase that message, but just the existence of the macro is fine. Expand to nothing. Otherwise, nodiscard lock and nodiscard ctor lock. Okay. Then we have ones about, these are for constructors. Thread, where if you create a thread and then just drop it on the floor, you never joined or detached it, well, that's bad. It's going to terminate. With JThread, that's interesting. Do we mark JThread CDOR as nodiscard? It is unusual to construct a JThread and then do nothing with it. Let's see. JThread. Okay, we did in fact mark JThread CDOR as nodiscard CDOR, so Alex is simply providing a reason here, and it does seem reasonable that if you spin up a thread and then immediately join at the end, why did you bother making a whole thread there when you weren't going to do anything else simultaneously? Very unusual. Probably wanted to wait until the end of a scope and then join. Yep, so that's reasonable to have. Async famously also has the blocking. Yep, and getting a future, if you get and then discard, yes. Okay, so these are all reasonable to have. Okay, so I like the existence of all these messages. And we found the, I think the allocate one was the case where we really needed to do an audit of the STL and find all of the occurrences. I'm not as worried about the other ones. I'll go review this later. And make sure we're not missing anything obvious. But from a brief glance, we're getting like all the remove, all the unique, and so forth. So overall, the direction of the PR seems right. And I don't think we're missing anything. I'm trying to rack my brain. Are there other cases where we had definitely applied nodiscard, but we didn't provide a reason, and we could provide a reason now? And this is getting all the ones, in fact, several ones that I did not think of. So it's great that Alex has done this. Getting all the cases where the reason for nodiscard was far from obvious. The other nice thing is that we talked to Alex earlier. This PR originally tried to add reasons, I think, for a lot of peer observers. That ended up being very verbose. It changed a zillion lines. Most of the time, the reason for nodiscarding something is that it's a peer observer, and it's not very surprising, except for like the empty case like we discussed, where if you call, stood find, you drop it on the floor, you get the nodiscard warning. There it's pretty self-explanatory, we feel. So using the plain nodiscard for the vast majority of cases, and then using the special macros for the cases where it's unusual, it seems to be reasonable for warnings that do not get emitted that often. They only get emitted under unusual circumstances, and then we just need to ask, okay, is the user going to be confused why they're getting nodiscard here? And the non-peer observer cases are the ones where it seems reasonable to have the macro. So I like the direction of this PR. I will come back to it after this and check all the grammar and make sure that we're not missing anything else. But I think this is good. So I'm going to hold off on submitting this review. But hopefully we were able to explore the reasons for nodiscard and why you should use it in your own code, especially like even if you're just maintaining an application, nodiscard is useful because everything defines functions and calls it. But especially if you're maintaining a third-party library, you should be using nodiscard as much as the STL. We are not only putting it on all of our public functions now, we're going back and adding it to internal machinery as we update it, because in our own code, we might forget to call something. And it's so easy to add, it has essentially no cost to the compiler, because it's just an attribute. It can, digest that token very quickly. It sets a bit somewhere saying, hey, if I ever see this discarded, I should emit a warning. But otherwise, it has no, interesting costs, especially the one that doesn't have a message at all. It's just, double bracket nodiscard, very easy for the compiler to parse that. So we recommend using it as much as possible. Okay, let me go through the chat, see if there's any remaining questions. Let's see, we talked about the bug that Cameron has already fixed. Casey advises, please use views take while instead of hacking find with a side effecting predicate. That is like take elements from this view until some condition is met, and that condition could be state accumulated in the predicate. Is that correct? Or the function object?
I don't really recommend stateful function objects, but if you're using find, right, if you're using find and you're hacking it with a side effecting predicate, your goal is to change every element up to the first one found that satisfies. some condition, right? So you
Yeah.
should pull out some condition into a predicate, use that with use take while, and now you
Yeah.
have a range of exactly the elements that you wanted to modify, and you can
That
use
makes
that
sense.
instead of this weird hacked find thing.
Yeah. And I think I've only seen 1 or 2 occurrences of that in the compiler itself. But yeah, that does seem like good advice.
The much clearer expression of programming intent.
Yeah, just write what you mean rather than sort of mangling the STL into something that does what you want. But like the reason we have named algorithms is that you can see the name and you have some idea of what to expect. If you get a find that's doing fancy, unusual, side effecty things, you probably shouldn't be a find in the first place. Checking the chat for anything else. Hi, Casey's kitty. Let's see. Let's see. Nicole does not like the name allocate object because it only allocates storage for objects, not actual objects. Yeah, that's a reasonable concern. Let's see. Oh, interesting that internal tools are available, but if it's not available to the public, then I won't mention that URL here. And Casey mentions we're up to 5,430 uses of nodiscard in STL headers. Funny thing, nodiscard is still going to be more popular than export. I only have about 3,000 occurrences of export in standard library modules. And that's because we not only nodiscard internal functions, but member functions. And export does not need to be applied to every member function. It only needs to be applied to top level classes. So now and forever, nodiscard will be the most popular thing. And oh, Cameron's already got a PR out fixing the bug, so that's awesome. Thank you, Cameron. Okay, I think we can end this review. Thanks for watching, and we'll see you next time on the VC Libraries Open Code Review.